Hello there, a quarter. And so let's say I picked heads and you picked tails. We're going to bet on this quarter and see who wins. What are the chances that your bet would win or my bet would win? Well, let's see. There's only two options that we can pick from, heads or tails. So let's say total outcome possible is 2. Well, you picked 1, I picked 1, so we each have a 1 chance. So 1/2, that's 50%. That's the chances, 50-50. And if I lost, that means you won. And if you won, then that means I lost. That's today's topic we're going to cover is probability. And what we just did is the simplest example. So probability is pretty much the number of possible outcomes over favored outcome. The outcome that will give you the win or give you the lottery ticket. So, knowing this, let's look at a die. Let's call this weird thing a die, and we know dies have 6 sides. What are the chances that a 4 comes up? Well, that's one number out of the possible 6, so we'd have a 1/6 chance. Well, that seems pretty easy, but what if we had 2 die? What is the chance of still getting 4? Well, one die is 1/6, the other one is also 1/6. But what do we do with these 1/6? Well, we'd have to multiply them. So, if we multiply them, our chances are actually 1 out of 36, which is a lot less than 1 out of 6. We just used the deep independent formula, which is A and B probability equals P of A times P of B. We just multiply them together. That's pretty simple. Now let's look at another example. Okay, so let's say this is a bag that contains 10 little marbles, and we want to find what's the probability of first grabbing a red one and then grabbing a green one. So, if we, let's say best case scenario, on the first time you get a red one, what are the odds of that? Well, there's 10 marbles, and there are 3 red ones. So that's our chance of getting a red one. Now, if we wanted to get a green one, we would have to multiply it by number of green, which is 3. But here's the catch. After you grab a red one, we're not putting it back in, unless if you explicitly say in the directions. So if we take it out, we only have 9 left. So that's how much left. And so our chances are 3 out of 9, or 1/3. So now we would multiply these together and get 9 over 90, which is also 1/10, or 10%. So this one would be a dependent event, because the second one is dependent on what you got in the first one, because there's less marbles. So the formula for here would be probability of A and B equals probability of A times probability of, here's some fancy notation, B given A. Alright, one more. So now, let's go back to the coins. So we have 2 coins now, and we want to find out when you'll get a tails, or maybe you'll get it on the first one, or the second one, or both. We just want to calculate what's your odds of getting a tails. So for here, we just find probability of first toss and second toss, which is still 1/2 and 1/2. But now, we want to calculate, well, so we have the probability of both of them, so we know that the odds of getting tails is 1/2 in both, but we want to find out the probability of getting tails in one of them, which will be 1/2, and the other one, which would be 1/2. But if we're also going to add them together, we need to find out the probability that both of them will happen, which means we have to subtract so we don't duplicate ourselves. So let's write 1/2 plus 1/2, which are the 2 odds, minus the chances that it happens at the same time, which is, well, you multiply them together, which is 1/2 times 1/2, and you get 1 minus 1/4 equals 3/4. And this last equation is P, A, or B equals P of A plus P of B minus P, A, and B. So we're combining some formulas here. Alright, so thank you for watching. This has been Independent and Dependent Probability Events by SATFreepractice.com.